Hello, thank you for attending my presentation today. I will be sharing a PowerPoint of a study called Auditory and Tactile Word Learning Among Adult Braille Readers. My name is Lindsay Harris, and I am an Associate Professor of Educational Psychology at Northern Illinois University in the United States. And if anyone wants to reach me with questions following this presentation or for any other reason, my email is lharris3@niu.edu. First slide, a little background about this project. There's a lack of research on vocabulary and concept development in Braille readers. And here I cite Savellano et al. 2014. We know that in print readers with typical sight, exposure to the orthography or spelling of a word during vocabulary study facilitates learning its meaning. And I'm going to use the words orthography and spelling kind of interchangeably in this presentation. So basically that if you're able to, in a print reader, see the spelling of a word while you're trying to learn its meaning, you tend to learn its meaning faster. And that's been found in children, for example, by Rosenthal and Airy in 2008, and in adults, for example, by Nelson, Ballas, and Perfetti in 2005. So, the first people, to my knowledge, that wanted to see how this works in Braille readers were Savellano et al. In 2015, who taught vocabulary to elementary age students with visual impairments who read Braille. And so these children learned words in either a auditory-only condition, where they heard the word and were told its meaning, or a simultaneous auditory and Braille condition where they were able to read the word while they heard it pronounced and were told its meaning. So unlike in past studies with print readers, the Braille readers actually learn the meanings of words in fewer sessions in the auditory-only condition than in the condition in which the word was simultaneously presented in Braille, which was really interesting. This is not what the authors expected. And by way of explanation, they speculated that simultaneous exposure to orthography and speech might be more taxing for Braille readers than for print readers. Because Braille is read one cell at a time or a couple cells at a time, unlike print where a whole word can be fixated at once. They said that working memory was taxed more, and therefore adding auditory processing to that might have led that condition to be more challenging than the condition in which the children were just listening. So that raised a lot of interesting questions. And so the questions that we set out to answer in the present study were, first of all, is an auditory-only condition more effective for word learning in Braille readers when compared with a Braille-only condition? In other words, a condition in which they're only reading, not simultaneously reading and hearing the pronunciation. So if that's the hypothesis or the speculation that the working memory was overloaded by processing in two modalities simultaneously is correct, then that should go away in our study, and we shouldn't see the disadvantage for the Braille. The second question that we were interested in is, how do word learning patterns across print readers with typical sight and Braille readers with visual impairments differ when directly compared. So to my knowledge, no prior study there were a couple studies showing that there was this auditory advantage in print readers, and this one study showing orthographic advantage in print readers, and then this one study showing an auditory advantage in braille readers, but nobody had ever looked at them all together using the same materials, the same equipment. So that was another goal that we had. So to do this, we decided to replicate the Nelson et al. 2005 study. Remember, that was the study in which adults either heard a word or read a word, and the orthographic advantage was found. And in that study, they had participants study words either auditorily or orthographically. So you can see here, if you're viewing this slide or this presentation, I have images of a man listening to a word and a woman reading print, and the word that they are studying is hebitude, which was one of our words. I believe hebitude means sluggishness, mental sluggishness. As you can see, it's extremely rare. We didn't expect our participants to know these words. And then they were actually tested on the words they had studied, either in the same modality or the opposite modality to that they had originally studied them in. So I have more pictures up here showing that the man listening was then either tested on hebitude by hearing it or by reading it. And the woman reading, the woman who had read hebitude in print, was tested on it either by hearing it or by reading it. We borrowed this design. We used the same words, the same adults, but we added a group of Braille readers to the group of print readers. And so here I have a little image of my man listening and woman reading print, supplemented with a man listening and some fingers reading Braille, to show that we had two groups, but now instead of listening and reading visually, we have a group listening and reading textually. And although we did follow the original study and had both a testing phase and a study phase, today I'm only going to be talking about our findings from the study phase of the experiment. Okay, so our method was we had 20 print readers and 23 Braille readers. These were all adults, and they all claimed to be proficient readers. And we had them study the definitions of extremely rare English words, 70 of them, in successive rounds. So I already gave the example of hebitude. Another word that they studied was napiform, which meant turnip-shaped. So you can see these are not words that most people would know, and indeed very few of our adults had heard of any of them. And for all participants, Braille readers and print readers, each word was presented either auditorily or orthographically, and each word was presented in only one modality for a given participant. So half of the print readers heard napiform, and half of them saw napiform. Half of the Braille readers heard napiform and half read napiform in Braille. So they would go through the whole stack of words, and before each opportunity to study a word, participants were asked if they recalled its definition. If they said yes and provided the correct definition, then the word was considered learned and removed from the stack before the next round of study. So that way we could track how many rounds of study it took before a particular word was learned for a particular participant. And this procedure continued until all the words were learned or 2 hours had passed. So we had 3 hypotheses before we did our analyses. The first one was that print readers would be more efficient at learning word meanings than Braille readers. In other words, we thought on average print readers would take fewer rounds of study to learn the definition. And that's because, as we mentioned before, there's a higher working memory load involved in Braille reading. The Braille readers have just more going on cognitively when reading, and so we thought that that might result in a couple extra rounds of study necessary to learn meanings. The second hypothesis was that both print and Braille readers would learn the meanings of written words more effectively than the meanings of spoken words. So you'll recall that when Saviano et al. Found that their Braille readers learned more effectively when they only heard the words, it was because they were getting too much information at once when they were both reading and hearing. But the Nelson et al. Study found that if they were only reading, these were print readers, were only reading and not simultaneously reading and listening, they learned better from reading. So we speculated that that should also apply to Braille readers, and so that in our study, the Braille readers would also get an advantage from reading rather than listening. The third hypothesis was that the Braille readers' performance would be more balanced across modalities than print readers. And our primary reason for thinking this is that people with visual impairments are quite practiced at listening to speech without visual cues, and so it's not so cognitively demanding for them. But sighted participants aren't as good at it, and so we thought they would be more disadvantaged by the auditory-only condition than the orthography-only condition. So our analysis approach was to use a mixed ANOVA. Our independent variables were group, which were Braille readers and print readers, and modality, which was auditory or orthographic. And the dependent variable was the mean number of meanings learned per round. So here are the results. Both main effects and the interaction term were significant with p less than 0.001. I'm not sure how many attendees of this conference are psychologists or behavioral cognitive scientists, but that's a pretty strong significance, which means, so let me unpack that a little bit. Hypothesis 1 was supported. Print readers were more efficient at learning word meanings than Braille readers. On average, they learned in fewer rounds than the Braille readers did. Hypothesis 2 was not supported. So both print and Braille readers learned the spoken words more efficiently than the written words. Everybody showed an advantage for the auditory condition, which was not what we expected. And hypothesis 3 was supported. Braille readers' performance was more balanced across modalities than print readers. It mattered less to them whether they were reading or listening. They did equally well, for the most part, whereas the print readers were more disadvantaged by reading compared to Braille readers. So we need to discuss these findings a little bit. I don't think we need to discuss the confirmed hypotheses so much as the supported hypotheses as the hypothesis that was not supported, because it's really interesting. So if you'll recall, Savaiano et al., 2015, speculated that the auditory advantage for the Braille readers that they saw was due to this working memory overload from processing in two modalities simultaneously. However, our study eliminated the need to process two modalities at once. So even though we replicated Savaiano et al.'s finding of an auditory advantage, we kind of disconfirmed their explanation for their finding because there was no simultaneous processing of auditory and tactual information. And Nelson et al., 2005, speculated that the orthographic advantage that they observed in print readers was because reading creates a richer memory trace for a word than listening does. And to break that down a little bit, they hypothesized that if you are listening to a word, you hear the word, but if you are reading a word, while you're reading it, you kind of activate its pronunciation in your mind. It's really hard for proficient readers to read a word without activating, to some degree, its pronunciation internally. And therefore, you're getting more information from reading than you are from listening, if you follow me. And so that was their explanation for the orthographic advantage, which we thought, well, that should apply to Braille reading as well. And so we thought we'd find this advantage for our Braille readers. However, we didn't even find it for visual readers. So our results really call into question both of these prior explanations that had been given, which means that more research is needed to account for these findings. There are a lot of interesting possibilities here to investigate. One is that because the quality of our recordings of the words being spoken wasn't fantastic, it's possible that the participants had to engage in deeper processing when listening to the words being spoken because they weren't that clear. And it created kind of a desirable difficulty in the auditory condition. So because they had to work a little harder to the spoken words, they were able to learn those more efficiently, is one idea. This still needs to be studied experimentally. This was the second study of word learning in Braille readers to find an advantage for auditory processing. Now, that's only 2 studies, and there isn't a huge population or sample size in either of those studies. We had 23 readers. Savaiano et al. Had 3 because they used kind of a single case design. So nobody should go out and rewrite their curriculum based on these results. However, a tentative recommendation is that if all you're trying to teach students is the meanings of words, then there may be something to be gained by teaching auditorily, by only exposing them to the sound of the words. However, that's rarely the only goal. right? Usually we want students to learn both the meanings and the spellings of words. And as you might guess, orthographic exposure is necessary to learn spellings. That's what Saviano et al. Found in their study. And additionally, Saviano et al. Found that all three of their students eventually learned the meanings of all words, regardless of whether they were exposed to them auditorily or auditorily plus Braille. So, if you teach words with just the spoken word, students will probably learn the meaning faster. However, if you teach it with exposure to the spelling, they might learn the meaning a little bit slower, but they will learn the meaning and they'll learn the spelling. So these are things to keep in mind for teachers of students with visual impairments, and the work will be ongoing, so I hope to attend a future conference and update you all on what we've learned. Thank you so much for your attendance. Again, please email me or reach out another way if you'd like to get in touch. I just have one final slide here, which are references, and I'll mention them all quickly. I cited Nelson, Ballas, and Perfetti, 2005, from Written Language and Literacy. Rosenthal and Airy, 2008, from the Journal of Educational Psychology. Saviano, Compton, Hatton. Yes, Saviano, Compton, and Hatton, 2014, from the International Review of Research and Developmental Disabilities. And finally, Saviano, Compton, Hatton, and Lloyd, 2015, from Exceptional Children. Thank you very much for your time.